Yeah, hello from Bonn. I'm happy to introduce our team, consisting of George, Marina, Lucy, and Akis. So the idea behind our project was, if you go to the next slide.
Mario.
Yes, perfect. Was actually very egoistic, to be honest. Here at ECMWF, we have created this new data set, which we call ERA 5 Drought. It's essentially a data set of drought indicators, which are calculated using the ECMWF reanalysis that exists since 1940 to today. And this data set is updated also near real time, so we get an update every month of the state of the drought globally. And I have a lot of friends and colleagues, and we also get a lot of media requests actually that ask us about specific drought events, such as, for example, the very recent drought in Brazil. And we got a lot of questions like, this must be the worst drought so far. And it actually takes a lot of work to dive into each individual drought and contextualize it. So we thought, like, this is a really nice exercise for people to get familiar with these data sets, and also to help us to create reproducible Jupyter notebooks that we can actually hand out to others and say, look, you just need to change the region and you can analyze this particular drought yourself. So this is how the idea for this project was born. And with this, I hand over to Lucy for the introduction.
Thank you, Jessica. Could I have the next slide? So as Jessica was saying, our project, we were focusing on the ERA5 dataset, which is a set of drought indicators, as Jessica was saying. We also created a Jupyter notebook, which we tried to use to tell a story of what we were doing and make it as understandable as possible. And then we also have the notebooks themselves, which we've tried to make as interactive as possible as well. So the specific data we were looking at in particular two drought indicators, the standardized precipitation index, which just has one variable, precipitation, and then the SPEI provides a broader understanding because it accounts for both precipitation and temperature-driven water loss through evapotranspiration, which is the hard word to say. We also looked at different accumulation windows from 1 to 48 months, and if you saw on the first slide there was a scale of the drought indicators, so -2 being extremely dry, i.e. a severe drought, and +2 being extremely wet. And we looked at the monthly data from 1940 to the current year, provided in net CDF format. So we had 3 main workbooks, recognizing drought events around the world and over time. So mapping current global drought conditions, identifying regions where droughts were currently developing or intensifying, and then generating reports summarizing the severity and geographical distribution of these events. The second notebook, we used the drought events that we'd identified and specifically looked at the severity of them in terms of the area affected, as well as the persistence, i.e. the duration, and if any of those drought events stood out as anomalous. And then in the third notebook, we took some other data and tried to identify if there were any primary drivers behind those drought conditions. So I'll pass over to Marina to talk about the first notebook.
Okay, that's my part. We dive deeper into the first notebook, that is the Time Machine notebook, and it's titled in this way because it is designed to exploring the drought events across the globe and over time. This first notebook is aimed for Oops, sorry. This first notebook is aimed for people that has little or no experience in analyzing climate data. So what we wanted to achieve is providing them with basic tools to explore this data, and at the same time, yes, at the same time, we even want that everyone can tailor his or her specific analysis suited for the purpose that he or she has. So to achieve these goals, we have try to keep the amount of code inside the notebook as low as possible, moving all the logic and the supporting function in separate Python files. And we insert a set of widget block to give the people the ability to choose their geographic area of interest, their accumulation window, and time period. Regarding the geographical areas, all the countries are mapped in this list, and we have even given the possibility to choose the sub-district inside this country, so even people with low computational power can perform some kind of analysis. Let's check if I said everything. Yeah. So we can let's go through some of this analysis. The country chosen for this presentation is South Sudan. The accumulation windows is 12 months, and the August is the reference month. The previous chart, please. Yes, this one. An easy way to approach the analysis is by visually exploring through a set of maps the evolving of the draft condition, and this can be done in a time-lapse format. So in this way, we can have a global vision of the entire country, as we can see in this map. The brown areas are those where the drought events are more severe, while the green one is where there is a wet condition. As we can see along the years, the 2023 was a critical year for drought condition. So given this first observation, we can move to the next charts, because once we have this preliminary observation, we can check our data looking for some statistical measures. In particular, now we can see a scatter plot where the user can compare the median and the media and the medium value, and in this way have an idea of the central tendencies. Instead, with the following box plot chart, we can have a more comprehensive view of the data distribution, looking even at the minimum and the maximum values of the range, the quartile, and the possible outliers. Next slide, yes. When we have found a peculiar event in a specific month of a year, we want to give the user the ability to check if all the other months in this year experiment the same conditions. As we can see in this example via a line chart, we can see that in this case, for all the year 2023, the South Sudan experiment drought events. Please, next slide. Now we can have a more comprehensive view combining months and years via two kind of stripe charts. The first one put the months and the years along the x-axis. Instead, the second one, stripe chart, that is yes, show the years in the x-axis and the month in the y-axis. In this way, we can have a global overview of the tendency of the drought in a geographic area, and both these charts can be created selecting the range of years. So now for this example, we have chosen from the beginning till the current year, but for people that has not the computing power to reach all this result can even choose a smaller range of data. Please, the next slide. Yes, finally, another important issue in evaluating drought events are the accumulation windows. In these such area charts, let people to check how the accumulation windows may vary according to the period that they are referred. In this case, we have compared 1 month accumulation period, 3 months, and 12 months. And so this chart can help everyone to compare the short-term and the long-term drought events. And this is the last chart of, this was the last chart of the first notebook, but we have even an additional notebook focused just on the current drought events at a global scale. So in this case, we can have a complete idea of the evolving of the drought globally, and at the same time, there are even the possibility to get a list of sorted list of the countries that are experimenting drought events in a certain year. And now I give the floor to George that introduces us to the analysis of drought events. Thank you.
Oops. Thank you, Marina. So the second workbook was focused on, after identifying drought events in a region, to set some baselines and then identify extreme events. Again, we still have South Sudan as our area of interest, and we can see the drought classification over time on this stripe plot on the left. And on the right, we can see a list of drought events that we identified, along with their duration. Next slide, please. So there were two main areas of focus for our analysis. The first one was the duration of the events and the area affected. Here we can see on the left the duration of all the events we identified in South Sudan through the years, and the blue line is the median, which it was 7 months. We have the 10th percentile and the 90th percentile, which can show us which events were extreme based on the history of the area. And it's very clear that in recent years, in the past 20 years, South Sudan had some extreme and long periods of drought. On the right, we can see a stacked bar plot that shows the area affected, and the the area, sorry, the size of the area affected for each type of drought. And again, it's very easily noticed that the last one, which was for more than 10 years, that most of South Sudan was affected. And finally, for each kind of drought, from mildly dry to extremely dry, we can plot maps that shows the area affected and group them into up to 1 month, 3, 6, or more, the 6 months. And now I'll give the floor to Akis for the next.
So for the third workflow, we were trying to identify the drought drivers, which after working on it a bit, we figured that at least the way we tried to figure it out was more of a chicken or the egg case. So to see if there is any correlation between the two, any relationship between the two, we tried accessing ERA5 variables and running Pearson correlation to SPI values. So for the ERA5 variables, what we did was set the same baseline time periods as was with the SPI, which was 1991 to 2020, and based on that, get the anomalies for the ERA5 variables. Those variables we analyzed were the potential evaporation, soil moisture, runoff, total precipitation, and temperature at several layers. And we considered time lags, which means that the idea behind it was to see if we eventually could train a model having the sum of the ERA5 values as input to predict SPI values as output, right? Well, we haven't done it yet, to be honest, because we run some, we identified Argentina as an area of interest, isolated the SPI values for the last decade, and run Pearson correlation on that. And we did find some linear relationships among several variables, while evaporation and precipitation made sense because those are used to compute SPI, but also we found some relationship with other variables. What was surprising though was that we didn't, there was a lowered consistency with temperature anomalies. However, based on this, we could go ahead and train a model using those variables at the lag times that we identified that there are relationships, and train a model to predict SPI. Lucy?
Thank you, Akis. So this is our final slide. I'll just summarize what we've done. So obviously we performed data collation and visualization. So cleaning the data and provide a way for users to view the drought events by country, year, time, accumulation window, and also the geographical distribution, seasonal variations, and trends. And then we provided a more advanced analysis, so discovering the statistical measures, mean and median, and ways to compare time periods against the entire data set, helping to identify anomalies and spot trends and understand drought evolution. And then also mapping out current global drought conditions, classifying droughts, and hopefully generating reports to kind of track and analyze ongoing droughts. What we've learned, a huge amount. So how to understand the SPI and SPEI indices, which is a new concept to most of us, to analyze the drought events, and also how to use these to classify droughts in terms of the severity and duration. And then, as Akis was talking about in the last couple of slides, looking at other external factors which may contribute to these drought events. Potential next steps would be a further exploration into these drought drivers, and also looking at additional data such as fire, flood, heat wave data, studying global and regional climate models, broadening the correlation investigation, and trying to find non-linear relationships, and as Akis mentioned, training a model to predict the SPI values at different lag times as input. One other idea we had, which the previous team reminded me about, was we tried to make the notebook as interactive as possible, but we did also talk at the very start of the project about a front-end way to do a similar thing, which is a bit more user-friendly. And that's it for our presentation.
Okay, thank you very much, team. You heard the run.
These are the link for the Jupyter book, where you can find the notebook and even the chapters, the introductory chapters to drug events. And just a few things.
Sure.
I'm not sure if we have already said it because I'm a bit emotional, but these data are not yet available to the public. They will be with the launch of the new CDS platform in autumn, that will be in autumn. So stay tuned, because we update the notebook to get the data from the CDS instead from the actual server. Thank you.
Excellent. Thank you, George, Lucy, Akis, and Marina.